So the first task template that we will discuss is the one for the classification task. And classification is maybe the best understood task for knowledge-based systems, and it's also a very common task in many applications. So what's the idea of classification? We're given an object and we're supposed to put it in a class, right? So for example, we're supposed to classify products or movies or rocks. So actually we were involved in building a classification system for rocks. That's what geologists do, right? So you give geologists a rock and they can classify it for you in any of a number of types. And then knowing the type is important, for example, for companies that do oil drilling, because certain types of rock are indicative of the presence or absence of oil. Okay. It's a very simple analytic task. There are many methods for it, and we will discuss one particular one. So the simplest method for classification is called pruning, right? So the idea is that you are being given an object, you generate all classes to which it may belong, then you pick a particular attribute of the object, you obtain the value, and then you remove all classes that are inconsistent with the value. So basically you start with a very large set of possible classes, and then you obtain a feature and you rule out some classes, and you obtain another feature and you rule out some more classes, until you are left with one or more classes that are potential classes for the object. So here is the corresponding inference structure, right? As promised, every task template will come with the template inference structure. So in accordance with what we just said, we start we are being given an object, we generate all possible classes, right? Then for those classes we specify an attribute, we obtain the value for that attribute, we match that attribute value with that class, and it tells us whether the object belongs to the class or not. And we can do this in many different control structures. We can either do this one feature at a time, or one class at a time, or all classes at the same time, or all features for one class at the same time, and so on. Right, so the next part of the template is indeed to specify such a control structure. Right, and here this while loop specify one of the options that I just discussed as a pseudocode in the task layer. So the previous slide was a template inference layer. This slide is a template task layer. And of course there are many different variations of this. And here is a template domain layer. So what do we need in the domain layer? Well, we need always objects and classes of objects. And these classes of objects, they have relation with attributes. And the relation is a constraint relation, namely saying that this class requires a particular value for that attribute. So an object belongs to a class, an object has certain values, and a class requires certain values. And this schema you will always find if you're doing classification. So knowing this, and it's not entirely trivial to come up with this, then knowing this allows you to start filling in this schema when you are encountering your particular classification task in your particular domain. Now here's an example of how that was filled in for the rock classification task that I mentioned earlier. Finally, it's useful to mention that sometimes classification can be subdivided into subtasks, each of which is classification. So we encountered this when we did rock classification. So rocks contain minerals, and in order to find out the mineral, you need to do a nested classification task. Namely, in order to do rock classification, you need to find out the mineral, and in order to find the mineral, you need to classify your minerals. And then you can classify your minerals based on color and all kinds of other things. Right, so this is a classification task on a subpart of the object as part of the overall classification task.